Welcome to the engine rooms of the Steamship Shieldhall, everyone. To my right here is the beating, steam-powered heart of what makes the Steamship Shieldhall so unique and special in this modern era. This is the very same technology from a long bygone era that powered the great ocean liners of old and carried millions of passengers year after year after year across vast oceans, taking them to familiar and new shores. In today's video, we are going to be talking with our very own Chief Engineer, MacKenzie. In his own words, he is going to be explaining how everything down here works. Aiding Graham's words are going to be some fantastic animations, very kindly supplied by the Mariners and Mirror podcast, who have allowed us to use their animations that completely remove all of the external layers of Shieldhall, allowing us to have a unique view of Shieldhall's steam-powered beating heart like never before. And with that out of the way, it is over to Graham.
Hello, I'm Graham MacKenzie. I'm the Chief Engineer on Shieldhall, a job that I've been doing since 2014. I've been a volunteer on board since 1994. I've got a fairly good knowledge of what the ship's all about, and I've been involved in all sorts of projects on board as well over those 30 years. Welcome to the boiler room. This is the boiler room on Shieldhall. This is the heart of the ship, and if things don't go right in the boiler room, it really doesn't matter what happens on the bridge or elsewhere on the ship. Nothing happens if the boiler room get it wrong. We have two Scotch boilers. The Scotch boiler technology goes right the way back to the late 1800s, and it was really a result of the Bessemer steel process, which was introduced in that sort of era. Improved the quality of steel, enabling greater pressures to be raised in the boilers. This was the sort of technology that took sail off of the commercial markets, because it enabled the steam engines to be more efficient and obviously became more economical. Each boiler contains approximately 25 tons of water, and to raise steam takes us typically 3 days. It can be done in a quicker amount of time than that, but we take 3 days basically to conserve the boilers, which are largely original. The fuel we use is marine gas oil, which is a variation of diesel fuel. The fuel is actually injected into the boilers by steam-powered oil pumps, and the air that comes in is actually pushed in under pressure into the front of the boilers. The steam is the most important part of this operation, and these boilers are absolutely fundamental to the whole operation of the ship. We are now up at the forced draft fan, which is one level above where we were in the boiler room. The forced draft fan provides all the combustion air that goes into both boilers. You may be asking the question, well, how does this get driven by steam when we don't have enough steam to drive the auxiliaries? And the answer to that question is that we have small electric fans on the front of the boilers, which provide enough air to go into the boilers until steam pressure has risen sufficiently high to bring the auxiliaries online. On some ships, they had a pressurized boiler room, which was quite different to what we have. This forced draft fan engine takes in air from the atmosphere and through trunking provides it straight to the boilers. We are now standing on the boiler tops, and on my left hand side we've got the funnel uptake, which is where the hot gases go after it's been through the boilers, up the uptake and out through the top of the funnel. On my other side here we've got the various valves which distribute the steam around the ship to the various places. So there's main steam for the main steam engines, we've got auxiliary steam, whistle steam, generator steam, steering gear, all the various aspects of the ship to distribute the steam around the ship. So from here, we would take the next logical step, which is into the engine room, which now takes the steam that we've now started to distribute into the various places on the ship. Welcome to the Shieldhall's engine room. Where we are now is the view that the passengers would see when they come aboard and be invited to visit the engine room. So you're on the engine room tops, and you would see the two main engines plus the various steam lines feeding them. So this is the logical progression on from the boiler room, where we've raised the steam and start to distribute it into where we're now starting to use it. So the next thing is we'll go down into the engine room itself and take a look at not only the main engines, but also the various pieces of the auxiliary equipment that provide all part of the life support system for the ship. Shieldhall was built in 1955, so the use of triple expansion steam engines then was not unusual. The last steamships were built around about 1960s with triple expansion steam engines, and then after that, then diesel engine technology took over for cost of operation, probably more than anything else. Right, now down on the bottom platform, or sometimes known as the starting platform, and I've got the engine room telegraph sat behind me, which is the way that the orders from the bridge are transmitted by the officer of the watch to the engine room. That is the direction ahead or astern, or also whatever speed they demand as well. This is then translated via the throttle valve and the reversing valve to determine the speed of the engine and also the direction it goes. The valve gear on the engine is what was known as Stephenson's link, which is very simple and is very easy to maintain. What happens is when you operate the engine, it gives a very quick response, and the result is that any movement of the engine is also a movement of the propeller shaft, because there is no clutch or gearbox between the engine and the propeller shaft. I'm standing alongside the port main engine, and by my left-hand shoulder is the main steam line coming in, which goes to the throttle. The steam goes by the throttle into the high pressure cylinder, which is the disc that you can see on the left-hand side. So the steam is used in that cylinder, passes through the valve into the intermediate pressure cylinder, which is the next one back. The thing you will notice is the change in diameter, and this is to compensate for the loss of pressure as the steam has been used in the high pressure cylinder, so the steam pressure drops, and to compensate that, but to keep force the same, you have to increase the surface area, hence the increase in diameter. Again, once the steam has been used in the intermediate pressure cylinder, it then moves through the valve into the low pressure cylinder, which is the final stage of the engine. This is Victorian engineering at its best, because this design again goes back to the late 1800s. This was the technology that took sailing ships off the market. Once the steam is finished here, there's virtually zero pressure left, and this is where the air pump comes in. I'm standing by the cooling water pump, which is beside me, and behind me is the condenser. The cooling water pump takes in seawater from outside and then pushes it through the condenser. The condenser is where all the waste steam from the various engines is sent by steam pressure. It's then cooled by the seawater through a heat exchanger system within the condenser and ends up as hot water, or as we know it as condensate. The condensate is then taken away from the condenser through into the hot well, and from the hot well the feed pumps then feed it through feed water heaters into the boiler. The whole idea is to try and keep that water as hot as possible, so that when it goes back into the boiler there is as limited amount of thermal shock as possible, so you don't have to waste heat reheating the water again in the boiler itself. So I'm standing alongside one of our air pumps now, sometimes known as a vacuum pump, and the idea of this pump is to take the condensate away from the bottom of the condenser, away up through a little header tank, which allows any oxygen in the water to escape before it goes into the hot well. These pumps are fundamentally important. If the pump fails, then the associated main engine has to stop, because otherwise the engine gets waterlogged, and we all know that water cannot be compressed and could cause serious damage to the engine. I'm standing alongside one of the feed pumps, and behind the feed pump is actually the hot well, which is the blue tank you can see in the background. Now the feed pump takes the water from the hot well and delivers it into the boiler through the feed water heater. The hot well, you may remember, is fed from the air pumps, which takes the condensate from the condenser, and then it's taken into the hot well through the feed pumps into the boiler. Standing alongside the feed water heater, which I mentioned before, and this is now on the final stage of the boiler water system. So we saw how the boilers raised the steam and started to generate it and move it around the ship. It's now been through all the machinery. It's now gone through the hot well into the feed pumps. The feed pumps have brought it this far, and it's now about to be injected into the boilers. The feed water heater takes the auxiliary steam on its way back to the condenser, i.e. exhaust steam, using that as a heating medium through a heat exchanger system to heat the boiler feed water up to virtually boiling point before it goes into the boiler. So as that water goes into the boiler, it's not only under pressure, it's also under high temperature as well. And the whole idea is to reduce the amount of thermal shock that you get into the boiler when you're introducing water into the boiler.
The Steamship Shieldhall is over 70 years old at this point, but it is only with your support that we can keep this fine vessel in steam. So please, visit the links in the description down below to see how you can support our historic ship. And if you're curious to see all of this and more in person, then please, visit our website to book your tickets on board Europe's largest operational historic steamship, the Steamship Shieldhall. We hope to welcome you on board soon.